Okay. First, a quick introduction about myself. Um, I am Mohammad Aliannejadi, an assistant professor at the IR lab. I can admit this person. In this building, fifth floor, University of Amsterdam. And I do research in a few directions, mostly conversational IR, user simulation, evaluation, and recommender systems. And if you're wondering, where is this guy? This is an old picture of me, early days of PhD. So you can get an idea what a PhD can do to you. This is a more recent picture. Looks like me, I guess. And as Maria mentioned, I was also attending ESSIR 2015 as a student. Actually, that was the first kind of event of my PhD. So this ESSIR feels quite special after 9 years as an organizer and also having Maria here as a speaker. So I hope in less than 9 years, one of you organize the event and invite me as a speaker, if you do. All right, then let's dive in. A bit about today's talk. This is a very new topic, right? So LLMs and their application in IR evaluation, this is quite ongoing. A lot of things are still debatable. That's why a good part of today's lecture is going to be interactive. And I would like to ask you to actively participate. These are small tests or opinion pieces or votes. So I would like to hear from you. And in most cases, this will be a discussion between you and someone else. So please find a pair because, yeah, you need to discuss with someone. If you are alone, maybe you want to move. And then the talk is mostly divided in three parts, LLMs as assessors, where I mainly talk about LLMs as relevance judgment generators. Then I will discuss the risks and biases that come with this. And then how we can use them as assistants in relevance judgment. And then finally, if there is time, I will talk about evaluating generated content. If there is not time, the slides will be available. The slides are self-explanatory, so you can look at them. I think it's useful. So let's dive in. Okay, as I promised, this is interactive. Please scan this. Let me go here. This is the same link if you want to scan. As soon as I see no phones, I will move to the next one. Also, people online, please scan this. Let me open chat here in case something comes up. You can type if you have any opinion at any point. Okay. So first question, which is this one. Would you trust LLMs as relevance judgment generators? Answers coming in fast. Also, people online, please. Okay, more no's. Still need 24 answers. You can think more or discuss with your partner. Just a very quick interruption. While you're discussing, please type in why would you or would you not trust LLMs as relevance judgment generators? You can continue the discussion. Already. No harm in using LLMs. Okay, I'm muted. There is one comment online. Are we only talking about general purpose LLMs or yes? So I think what you mentioned in your comment online can be an argument itself. So if you think it's domain specific, yeah, that could be one reason to use it or not to use it. Okay, side information needed to disambiguate. Never used LLMs in my research. Would like getting your papers accepted these days. Did give a nice answer. Oh, it moves. Bias, okay. The ethical implications, interesting. No harm in using LLMs. Machine can understand text like humans do. Okay, they are just yet another model, better than crowd workers. So we see there is a lot of concern about hallucination. Uh, okay, let me see the new ones. Not expensive, so I guess this is a yes. If you know how to use LLMs, okay, we still don't know. LLM is all you need. Okay. I think you should talk to this person that has not used LLMs yet. LLMs are prone to generating false or inaccurate information. So interesting input. So what we see, I think, is a trend of bias, lack of knowledge about how LLMs work, hallucinations. So again, some risks. Reasons to use it, it's not expensive. They are intelligent. Some people say they are not intelligent. Did I miss anything? And it's just yet another model. Why don't we use PM25? Okay, great. Thanks a lot. I think this was very interesting. Let's move on with the slides. Okay, so I'll get back to this. My own opinion about this, which is very much in line with yours. But before that, I would like to talk quickly about this work. Very recent work is going to be presented in SIGIR next week. This is the work that they basically, on a large scale, they tried GPT-4 as a relevance judgment generator. And they basically curated feedback from the users. So they got feedback from real users carefully. And then based on that, they adapted their prompt, also their LLM, how they use it. What they notice is that in this plot, we see that LLMs can be very cheap. So on the x-axis, we have the cost. And then on the y-axis, we have agreement with the crowd. We see that LLM accuracy is even better than employees of Microsoft Bing. And it's even better than the best crowd that they have. And it's way further away from the typical crowd that they have. So this is what they observed there, but they do mention in their findings that this is not as simple as that, right? So they invested a lot of time, a lot of money, energy into making it work for one simple task, and they have all the resources that they can, like you can imagine. So this is probably not something that everybody can do. Again, we go back to one of the comments you had. We don't know how LLMs work. If we knew, it would work. Uh, so I think these are more or less a summary of what you also said. It's good. So the opportunities of using LLMs as relevance judgment generators, it's cheap, it's fast, it's consistent compared to crowd because you can repeat and get the same result in most cases. It's pretty much accessible nowadays through APIs at least, and it's scalable, right? So you can go large scale. What are the risks? Lots of unknowns, right? So we don't know how LLMs work. We don't know what will happen if we use them in terms of propagating bias and lack of diversity with humans. Every human thinks differently, but if we have two instances of ChatGPT API, there is not much difference in it. Something that one of you mentioned is yet another model. Can we really trust the model to evaluate another model? Safety, again, we don't know it very much, so it can be really harmful. And at the end of the day, we really don't know what we are optimizing for, right? Are we afterwards training models that can just satisfy GPT, Llama, or actually the user? And this is something that we'll get back to, where we actually see some discrepancy there. Another activity. So if you go again to the website, or if you are new, you can scan this. This is the same QR code. I just need to move here. So here we see more or less a uniform distribution. If you were to use LLMs as assessors for relevance judgment, how would you do it? It could be prompting, fine-tuning, anything you can think of. Again, you can discuss together. I'll give you 2 minutes for this. Okay, we have more than half of people entered the response, more coming. By the way, this is not the only medium we have. You can also speak out. If you have any opinion you want to share, feel free. So this is a word cloud. So we see that a lot of people would go for prompting. Also, fine-tuning has some fans here. Instruction tuning. Let's see if there are anything interesting here. Chain of thought. So that probably also is categorized as prompting here. I think I saw step by step. I cannot find it here. What do you mean by step by step? Does the person want to say think step by step? Uh, yeah, it could be that, or it could be that as in design. So yeah, maybe. Ask for explanation. Yes, this has been shown to work. Okay, knowledge distillation. Any comments here? So I think, oh, by the way, what do they mean by manual? Okay, interesting. So yeah, I think this person is the no LLM person, probably. Uh, okay, great. Thanks. Let's go, go back to the slides. Uh, so again, in line with most of what you said, there has been already work on prompting, zero shot, one or few shot examples as well as prompts. And also there has been work on fine tuning. We're going to go over some of these works and then discuss their findings and yeah, put it in context. Before that, I would like to give a quick uh, exercise. So you could think about it or just open ChatGPT or Gemini or Reka, whatever LLM you would like, and then try to come up with a prompt to assess the relevance of this query to this document that you can find here. This is a different QR code to a Google Doc. And then whenever you're done, you can enter your prompt here. Yes. Here it is. It's a Google Doc, right? It's I put the right QR code there. Okay, first one. I cannot read this one. Oh shit, sorry. Somebody prompted no. Did it work? Your task is to assess the following passage. Okay, I'm gonna give 1 more minute uh, in case you want to enter your prompt. The solar and wind energy or to review. Okay, so from what I read here, some people trust the LLM to know the definition of relevance. So they just directly ask if this is relevant. Some people give a range answer between 0 and 1, 0 and 2. Some people define, ask the LLM to act as an expert. Some people ask for explanation or try to extract information from different aspects. The key, let me see if some people refer to some tools. See if I don't miss anything here. Okay, thanks. I think we get the gist of it, right? So it's in most cases zero-shot prompting. Some people ask for chain of thought. Some people ask for explanation. Um, some people define the range. So these are all different ways of prompting. All work to some extent depending on what you're looking for and on the domain. So, and these are the 5 different prompts that we have seen in the literature so far, and some of them are in line with what you just entered. So prompt 1, is this document relevant? So we had a few of these. You trust that the LLM knows the definition of relevant, and you trust that it's in line with your definition of relevance. And then prompt 2, what is the level of relevance from 0 to 4? We also had this. You give a range because that's the output you're looking for. You want to get a clear definition, but still we don't know if the definition of 4 or 3 that we have is in line with what the LLM assumes or knows from training. That's what P3 does not assume. So how would you assess the relevance of this document given the defined labels? So you specifically define what your labels are so you can control the output to some extent, or at least you have a better expectation of what the output would be. So these are some examples of zero-shot prompts, one or a few shot. Evaluate this document compared to this other relevant document. So you assume in the collection you have one relevant document, and then that makes it much easier because you condition the relevance and the prompt on that document. And then the task of LLM is to look at documents that are similar to the given document. And then some people also tried evaluating documents given multiple documents, so relevant, semi-relevant, or irrelevant documents. So you give more examples to the LLM. Last year, there was this paper perspective of large language models for relevance judgment. So that was more or less the start of this paradigm in information retrieval, where they discuss in this paper, they test GPT and U.com on this task. And so they use it like what you did. You are an expert. Please assess these documents. They tried various ways of prompting, defining the definition of relevance, defining the labels, and test the models. And they come with this spectrum of involvement of LLMs, right? So they come from no involvement. So basically that would be human judgment, like what we do these days. So we do not trust LLMs at all. And then humans just keep doing this. And then a bit further away is where humans have full control on judging, but we use LLMs as some kind of tools. They can highlight, summarize the text, and provide some other things. AI assistance, so human and LLM can work together as some kind of collaboration. Then further on is human verification. So we could have two LLMs to generate the judgment, and then one human decides which one is best. And then again, LLM can generate and human can accept or reject. And this can also be multiple LLMs. Thank you. And then on the very extreme end, we do everything automatically with LLMs without any involvement of humans. This is what they proposed. This could happen. We are still not sure which one is best. And basically, that's the next question we have here. I want to hear your opinion. How would you use the LLMs in this range? Where do you think we can, let me go to the next question and then go back to the QR code. So in your opinion, where should we be in this spectrum? Please discuss it together based on what you have seen, the papers you have read, or what you think, which one is more trustworthy or more reliable. Sorry, it seems that I have the wrong question there. Okay, people are already answering. Let me see. I think yes. So this is for this question. Okay, let's. Sorry about that. Now that people are answering, I think. Let me rephrase my question. So as you can see, from the 5 options of prompts, let's first pick the one that is your favorite, and then we go to the next question. What's your answer, Sean?
Number 5. I like voices.
Okay. Okay, I think we see a clear winner. Most people think that prompt 5 works better. Evaluate these documents with these relevant and irrelevant examples in mind. So you have few short examples of different labels, and more than half of you think that if LLM sees these examples would perform better. We'll get back to this. And then let me see. I hope the next one is the next question. Yes. Let's get back to this. So how would you use prompt 5 in this case now? Would you use it completely independently or with humans in the loop? I'm going to go to the answers later, just not to bias you. Remember, so it can be fully human, no LLMs. This is for our no LLM friend. And probably this is for our LLM is all you need friend. But I think the rest of you are somewhere in between. Okay, let's see what we have so far. Produces a judgment that human can accept or rejects. Okay. So it seems that mostly people are with 4 and 6, which is balanced competence. So you're thinking mostly that this should be a kind of a collaborative effort, right? So we cannot fully trust LLMs, but we cannot also ignore them. They show some potential, and that's why we are having this lecture. Great. I see our LLM is all you need friend is still, but our other friend changed their mind. Okay, great. Cool. Let's continue. So thanks. Again, if you have any opinion you want to shout, please do. And also questions, please do shout. The same goes to online people. I have the chat open here. So in the same paper, basically what they compare is different options we have. Like, so we have actual users as assessment generators. They compare them. So actual users are actually somehow free, but only available to big companies, of course. Experts are the most reliable ones, but also the most expensive ones. Crowd workers, cheap, but not that reliable. And LLMs are categorized as very cheap and more reliable than the crowd. This is very much in line with what people are being reported. And they do experiments in this work, which is very interesting. So this is the actual prompt they issue to GPT 3.5. And they report on binary relevance labels. This is the confusion matrix comparing GPT and UChat. And this is based on the graded relevance. In the paper, you can also find the binary relevance, which is better. So we see what we observe here is that they seem to be okay, but they are not that okay, right? So there is not a lot of agreement between the labels that humans generate, so which is these ones, and the labels that LLMs generate, right? So the Cohen's kappa is 0.4 or 0.5, right? So they are not actually that good at the end of the day, at least up to this paper. So yeah, I think this is more or less what I just mentioned. So we see high agreement for highly relevant documents. So when the relevance labels is 3 or 4, it seems that this document is perfectly in line with the query. So that's probably an easier task for the LLM to also agree with human, but we have moderate agreement when it's somewhere in between. But what they observe is that if you use LLMs to assess all the documents in the relevance pool, so assume you have, for example, in the text setting, you have 20 or 30 different runs. You take all the documents, you take the assessment pool, you assess all the documents using an LLM instead of human, and then you compare the ranking of the models, because at the end of the day, that's what we care about, at least in Trek, right? So we want to see if model A is better than model B. And this is what an interesting finding that they had in this work, where they saw that we have a very high correlation, Kendall star of 0.86, when we rank the models using LLM-generated assessments versus human-generated assessments, much higher than when we look at the labels individually. This is something that was also confirmed in another work by someone in this room. Sean, the same year at SIGAR 2023, tried LLMs as one-shot labelers. So this was the example that we also had earlier. So you give a relevant item already from the humans. It could be assessed, or it could be the document that the user, for example, clicked on, in the case of MS Marco. So you give the relevant document, you give the document that you want to assess with the query, and then you ask the LLM to give you the relevance score or predict the label. They also, from a different perspective, like reach to the same finding. So if you have the recall precision curve, and then you pick the best F1 measure, which is not easy to find, as they mentioned in the paper, we see that we do not reach that high of an F1 measure, right? So they cannot directly replace manual curers because F1 measure is too low. And then also it's very difficult to pick the best F1 measure in practice. However, they do a similar experiment where they regenerate all the labels in the pool, and they rank the models, like Trek models, compare LLM generated, human generated, and they reach an even higher correlation. So almost 1, right? So we see that here, we see that they are really reliable LLMs for ranking models instead of individually predicting the labels. And not surprisingly, they are better with precision-oriented metrics, because we always shallow pool. If we go deeper, probably we can get better results with recall. But this is what they found and what they experimented in this. A quick bracket here. Sean is very good with releasing codes and stuff. You know, IR datasets. You saw in his talk. Also, we have been working with this package. This is the same paper integrated with IR datasets. So I highly recommend checking this repository if you want to like use the code or generate relevance labels, etc. Okay, so I want to dive deeper on experience that we had ourselves as track organizers, track ICAT. I think it was mentioned in one of the student talks yesterday, the Interactive Knowledge Assistance Track, or ICAT. It's about conversational information access. So I call it a strange case of ICAT because it had us thinking for a few days before we figured out what was going on. So we had some runs in the pool, CEST mostly listed here, the baselines. And then we got some inspiration by some runs, and then we started developing more runs because we wanted to also have our own model, potentially publish it. And these are mostly here on top, except for one of them. However, strangely, as you can see here, whatever we tried did not work. Like, so this run is the one from the original pool that was assessed by humans. You see the number is quite high compared to other GPT-based runs, but these runs did not differ that much. They are more or less the same. Let's admit this person. But in terms of performance, they are very, very different. Even if you compare them with other runs from the baselines, simple runs like MonoT5 or the run submitted by InfoSense team, which was based on Llama, we could not get any improvements. So we were wondering, oh, what is actually wrong? Can anyone make a guess? Or what would you do? Like, what would you check? Would you check the code for bugs or something else? Yes. Yes. Okay. We already got the answer, but I'm going to walk you through that, how we arrived there. So I hope you recall Maria's lecture on the Cranfield paradigm, right? Anyone remembers that? Remembers that? Great. So this is for those who do not remember. This is from Maria's presentation. So in this paradigm, when we want to have reusable collections, we do top K pooling. We cut off the ranking of different models. Top K, we remove duplicates, and then we assess the relevance, and then that's presumably a reusable collection. What happens to documents that are not in the pool or are not assessed? In the Cranfield paradigm, what do we do with them if we have a new model and then a document pops up, is not assessed? Any idea? Yes, you assume they are non-relevant, right? That's the basic assumption we have. And then that's the next question. What if you have too many of them? Is this still fair? Oh, what happened? So that's the problem, right? If you have too many unjudged documents at the top of your list, then you have this unfair evaluation. And this is actually what we noticed, right? So we looked at judged at 10, and we saw, okay, this one has 10 because it was in the original pool. All the documents were judged, but we have some of them 2, some of them 1.5. So we saw a high correlation between the number of judged and then the performance. And that was a real problem because probably these models are as good as the other ones in terms of what we did. They are very similar, but they were not in the original pool. So then here comes the next question, which was also addressed in other works. What if we have too many unjudged unjudged documents. So the reusability, first of all, the reusability of the collection would be questioned. There are old works that test this. So there are tests for this, but rule of thumb, if there is too much, it's not reusable, right? Okay, people are waking up. So then the next question is, can we use LLMs to fill the hole? So we saw that we could, to some extent, trust LLMs for relevance judgment. This would be one application. Can we get an old collection and then probably with all the new models, the way we are handling vocabulary mismatch, for example, we would get a lot of new documents in that are not judged, or maybe even the collection is updated. So then the question is that, do we really need humans, or we can trust LLMs for this? And this is what we studied in this work. So one approach to answer this is to, similar to the two works that we saw, regenerate all the labels, right? And we already saw that it's to a great extent okay to do this if you compare the models, right? And this is the results that we got in a little bit of different setting. We tested, and then this is to predict individual labels. So we compute Cohen's kappa agreement between the relevance labels of humans and then LLMs. We see these are GPT models. So we see that one shot is better than zero shot, not surprisingly. One shot is still better than two shot. So yes, that was exactly our reaction. Most of you voted for two shot, having one positive, one negative, but GPT, at least GPT, is not doing well with this setting. Not surprisingly, llama prompting does not work that well. We have it here. It's not really reliable. However, when we fine-tune llama, we achieve a very high performance in terms of individual labels, right? So we can really, to a great extent, predict what humans would say for in terms of relevance for these documents. And this llama 1 is pre-trained on MS Markov for the task of relevance judgment, and then we use it in this setting. Works okay-ish, but the task, I think, is too different to be generalizable. So again, inspired by the works we saw earlier, we said, okay, let's also rank the models and see what we do, right? So can we rank the systems and get a higher correlation? This was also surprising to us. Even though Llama 3 fine-tuned, it's very high compared to GPT. It's a very high Cohen's kappa agreement with human labels. But when we use these labels to rank systems, GPT still does better. As you can see here, different settings for GPT always, except for reciprocal rank, are better in terms of ranking systems. And in general, the numbers are similar to what we saw already in other works. So nothing surprising there. The only surprising thing is that we see a big difference here. You see the difference here, 0.7, 0.5. But here, GPT does better in ranking them. So what we conclude here is that it makes sense, right? So when you fine-tune Llama, you are showing a lot of labels of human assessors, and then the model learns to align with humans in terms of what is positive, what is negative, what is in between. And this is not something that GPT has seen, probably. Data leakage is a big topic itself, but let's assume has not seen this task, and then has its own biases, probably not aligned with human assessors that were hired for this task. However, apparently, GPT in this case has a better understanding of the concept of relevance. So when you assess the whole pool and you use all that assessment, it has a better, it aligns better with what humans do in terms of placing the models, right? So it had probably everything is shifted a bit higher. It's in general positive, but then models are ranked more or less the same. Yes?
I'm wondering how consistent the answers of the LLMs are. Can you say something about that? So if you ask the language model the same questions in the same query and the same document again.
You mean two LLMs compared to each other or the same? I think so. In general, they are. If you compare them to human, they are more consistent because okay, you have different random seed, blah blah temperature, but still it's the same model. Two humans can have very different. So that's one of the advantages of using LLMs in general. But we have not tested it, but that's the basic assumption in the literature. Any other questions? Okay. And another experiment, we were interested in simulating a real experimental scenario, right? So assume you have an old collection, and then you have your new model, and then you want to test it. You see a lot of unjudged documents in the top 10. What do you do, right? So you have a new model, a lot of unjudged. In this case, what we did, we simulated. So we took one model out of the relevance pool. We took all of the documents that were judged for that model out, but we did not. So we only kept those that were also in common with other models, right? We only took out the unique ones, and then we want to answer the question: can we use LLMs to fill the holes here, right? So what can we really assess the relevance of these documents and then see how they do in the rank. Okay, this is more or less what I just said. What we did here, we did this for every model. So let's say you have 20 models. We took out every model at a time, and then we repeated everything just to have different levels of unjudged at 10, and also different models, like in terms of architecture. What we see is very interesting. So let me explain to you what this plot is. So on the x-axis, we have unjudged at 10, right? So different models, depending on how similar they are to the rest of the models, they have different unjudged. We have the range between somewhere near 0 to somewhere near 1. And then what we do on the y-axis is that we look at that model. If that model is ranked, for example, at 10th in the human assessment table, results table, and then when we have the relevance judgment by the LLM, we use that to rank that model, and then we look at the difference. So if it was ranked 10 and now it's ranked at 8, the difference would be 2. Right? So the lower the better, basically. We want 10 to be 10 again. That's the perfect scenario for us, right? So these are the two models. One is Llama and one is GPT. I want you to think a little bit and guess which curve is which. Which one is GPT? Which one is Llama?
I guess the bottom one is GPT and the top one is Llama because
Who?
GPT is a stronger model.
Who agrees with Sean? Who thinks the top one is GPT and the other one is Llama? 3, 4 people. So how about the rest? You're not sure? So most of you think that this is GPT. However, you are wrong. Um, we were also surprised, so you're not alone in that. But it's then easy to actually justify if you think about it, because what we saw earlier was that GPT is not good at predicting individual labels, right? Since we are replacing the plugging in the relevance judgments of a single model, if the biases are very different, so everything is shifted. So usually GPT is more positive than human. Therefore, all the metrics are higher. So if the average of human, for example, is 0.4, that goes to 0.6. And if you compare one single GPT relevance judgment with all other human judgments, that usually goes higher in the ranking. Makes sense? And then we saw a very high Cohen's-Kappa agreement between llama and human. That also explains here, because llama learns the biases of humans, so it's closer to human labels. And then if we just plug in those labels, we are closer to the actual rank. Yes, exactly, yes. So this is more or less what I just mentioned, but some conclusions here is that if you are in a situation where you have a lot of judgment models, this is what we found and concluded. If you want to use GPT, you're better off doing like reassessing the whole pool, because of all the biases that we just mentioned. You want everything to be shifted, not only one single model in the ranking, and you get the best results, obviously, from our experiments and others. But if you are only assessing the documents of one single model, GPT is too positive, so everything will be shifted up, and fine-tuned models are usually better. It's hard to say if this one is better than assessing the whole thing with GPT, because we cannot really compare them. But I think they should be comparable. Let me see what's next. I think we can have a very quick break. No, let's yeah, we have 20 minutes, so it doesn't make sense. Okay, let me then move a bit faster. So these are some mentions of very interesting works on the same line. I just want to quickly mention so that you have them as pointers in the slides as well. So people in this work did similar experiments on TrackDL. They compared GPT 3.5 with Vicuna, and then their findings were similar to the regenerate findings, because they remove randomly, and in some cases they balance even the labels from the pool. So this is the removal percentage. So they look at different strategies. If they replace everything by 0, of course, everything goes down. If you use GPT 3.5 or Vicuna, GPT 3.5 here is better, not surprisingly, because again, this is not one single model. This is just relevance labels removed from the whole pool, and then you replace them. It should be better than Vicuna. That's in line with the findings of other papers, more or less. And then in another work, they they compare the relevance judgments generated by fine-tuned llama again with a lot of query performance prediction models. So if you put it in that context, query performance prediction also wants to predict to some extent how hard or difficult a query is, which kind of relates to relevance judgment prediction in a way, but they do it directly in this work. They predict the relevance judgment of documents, and then they use it as a proxy to predict query performance prediction. What I just want to mention quickly is related to the findings of Sean. For on a shallow depth, so you have for precision-oriented metrics, you are doing well. But for recall-oriented, you can go deeper. What we saw is that you get some improvements, but at some point it converges. So something around 100 or 200 is enough. And we can see it in these results here. So already with the depth of 10, the model is able to outperform all the baselines. And then if you go further than 200, you basically don't gain anything. And this is the plot. We see here, it saturates here. Okay, now with these things that I discussed, I want to know your opinion again. See if, not this one, let's answer it again. See if there is any change of heart here. I go here not to have you biased. There is a comment online. Okay, let me see. That is interesting. So we see a bit more shift towards 7, and 2 more people now think LLMs are all you need. Okay, so it seems that some people are a bit more convinced now that we can do more with them. We can go. Let me go to the slide. We can go down the spectrum. Thanks. So let's wrap up this part. What we discussed is that LLMs, like the labels generated by LLMs, correlate highly with the labels generated by human in some cases, but if we rank the systems, we look at the ranking, they correlate very highly, but less so if we look at individual labels. And there are certain biases of LLMs, but fine-tuning helps to align better with humans, obviously. Then I would like to move to the next part. I think I'm going very slow, but the slides will be complete, so you can still look at the rest. Okay, so let's do this quickly. The next question, let me see, what was it? I don't remember it now. Okay, so I have a quick exercise here for you. Please look at this query and look at this document. As a user, I mean, you could also search, use your phones or laptops, fine, but preferably not. Just say if you think this is relevant or not. You don't need to read all of it. We don't have time, but make your best guess. I'm sure not to bias you. Let's give it one more minute. I can already tell you the next one. Can you also try the same query and document with LLM with your prompt or a different prompt to see if LLM agrees with you? For those who already submitted their answer, they can do that. Okay, I think luckily my point is there. I was hoping most of you say no. So more than 80% said no. And then, oops. And then let me see, the next one should be the LLM. Yes. So once you have the result from LLM, I'm curious to see what you get for your prompt. Okay, let's give it 20 more seconds. Okay, we have a few, but I'm gonna stop here because my point is already proven, again, luckily. So most of you get a yes from LLM. Why do you think that's the case? Why do you think LLM is wrong? Who says LLM is wrong in this case? Why?
Slightly extrapolating the text that well things do matter for the population change, but yeah, it's not exactly written there.
Okay. Okay. Not exactly written. Any other opinions?
Kind of has the answer to the question, but find the answer in this text, you need a little. Like I'm not sure if it has the answer to the question. The question is very, very specific, and the answer is huge.
Okay. So you say the answer is somewhere in the document, but
Maybe I'm not
May.
sure I might skim.
Mhm.
It looks like it is there.
Okay. Yes.
Talking about this query is relevant, but it doesn't give an answer to this question.
Okay, it's related but not fully relevant.
Not a direct answer.
Direct answer. Okay, great, thanks. Then I have a quick question. You see this image? This is somewhere in Amsterdam, a bus, and assume you have this query, picture of a cat. Who thinks this is relevant? One, two. Who thinks that this is irrelevant? Okay, most of you. What do you think an LLM would say? LLM would say it's relevant? You found it, right? Yes, so it's, the cat is here. So it's more or less something that all of you to some extent said about the document. So the information is there somewhere hidden in all the text. You have like 10 pages of text and then one sentence could have the answer. Something like here, right? This image has a cat somewhere, but humans don't see it, right? LLMs can see it in the text because they have this huge context size. And probably, I didn't test this, but let's assume they see the cat here as well, and they assume the cat is there. So that's the point here. So LLMs can be correct, right? So that document does have the answer. Somewhere it says that in 1750, the population of Amsterdam is X compared to Paris or other cities. But it's not useful, right? Because as a human, you are not going to read the whole document and then reach. So the LLM is evaluating something different. I don't know if my point is clear here. So this is about what you consume, not what is there. So when we evaluate the relevance, fine, it looks at the whole document, it finds the answer, and it says it's relevant, but probably no human can reach there to find the answer. So even though it's true, it's not true. And this was one of the findings of this paper to appear in, I thought SIGIR, but I couldn't find them in the accepted papers. But anyways, the paper is on arXiv. They do a large-scale study of RAG models for federated search, and where they annotate a lot of documents with LLMs and compare them with human annotations, and they find a lot of these differences. And when they studied deeper, they found that, okay, in a lot of cases, LLMs are correct. They thought initially the LLMs were wrong, but then they found out, oh, the information is actually there. It's hidden, right? And that's something that one of the biggest differences between humans and LLMs, and some kind of, again, unforeseen effects of using LLMs.
Maybe then this kind of principle that it can make irrelevant documents relevant, so it can help
Yes.
extract this platform.
Yes. So if you use it as a question answering agent, right? But here we are using it as a relevance judgment tool, right? So it's still, I would say that is relevant to another model, but that is not relevant to a human. That's the difference. So let's go back to the paper that we mentioned in the very beginning, right? So they also mentioned some risks of using LLMs for relevance judgment. So how much time I have? 7 minutes. So they do mention that LLM performance varies with prompt features, but also varies unpredictably with simple paraphrases. This unpredictability reinforces the need for high-quality gold labels. This is also something you mentioned in the beginning, right? So there is a lot of things that we cannot control, we don't know how to control, and we are not aware of. And these are all the risks that come with using LLMs as relevance judgment generators. We already mentioned the positivity bias of GPT-4, right? In the work, we saw that everything is more positive, models go up. So let me see. Yeah, so what they found in this work was that since GPTs are more positive, so it's more like the non-relevant labels are more reliable than relevant labels, right? Because obviously, if it's too positive and says something is negative, most probably it's more reliable. And in this work, what they did is an interesting study. So they looked at the vulnerabilities of GPT-4. So they did some attacks to the model, and they saw that if you stuff keywords, query keywords into the document randomly, you can actually fool GPT-4. right? So let's look at it. So this is the way they did it. So assume you have the document and then you have the query. You either put the full query somewhere randomly in the document, or you put the query words at random positions, and then they ask GPT again for the relevance label. And this is what they got. I don't know why it looks like this, but okay, this is part of the bar plot. So it's important to look at the yellow and the green ones. We see that that's where a GPT is fooled, right? So in these cases, the non-relevant document is being labeled as relevant. So even though they look plausible and robust, but you can easily fool them. That's what they conclude in this paper. In another paper, where they call LLMs as narcissistic evaluators, I think this is something that a lot of people expect and already mentioned in a lot of work, mostly in NLP. If you want to evaluate generated content, you should not use the same model to evaluate, because they always favor their own. And this is a very nice plot they have in this figure they have in the paper, where they show this. Bart with Bart gets the highest score, and the rest for others. This is also something we also saw in ICAT, where we had we evaluate groundedness and naturalness of generated responses using GPT-4, and we had only one GPT-4 based run, and it was labeled as perfect by GPT-4, and in terms of groundedness, almost perfect. So it's like, okay, of course, GPT giving a medal to GPT in this case. So let's wrap up quickly. Very quick, I wanted to mention the risks and biases that have been studied so far. There is browsing and reading models are very different between humans and LLMs. Humans get distracted, get fatigued. LLMs are not like that. They pay attention to the whole thing. If we rely on LLM-generated relevance labels, we optimize for them, not for humans. They are correct for the wrong reason again. A lot of other risks are unknown. That means also there's opportunity for research if you want to do research there. And then something that is a bit more scary is that we don't really know what happens in 10 years if we fully rely on LLMs for relevance judgment, because these biases all reinforce themselves, and we have this feedback loop. It's really hard to predict what happens. Okay, there are two things left, LLMs and annotation assistance, and then I have a couple of works talking about evaluating generated content. I recommend looking at the slides. They are interesting works. And quickly, if you are interested in this topic, there is a workshop going on at SIGIR. You can no longer submit the paper, but you can check the papers there. There will be a panel discussion. There will be a virtual event you can attend for free. And there is also a challenge, LLM Judge. So the prompts that you generated today, maybe you can test them there, participate. Here's the QR code for it, to the website and to the page of the challenge. I think that's it. Thanks a lot. Questions? Well, I'm here every day, the whole time, so feel free to talk to me later about this, and thanks. Enjoy the coffee. Yeah.
So you asked us, are LLM, or to what extent LLM can replace a human judge? You cannot be everywhere, there people who can settle. I just wanted to get your opinion on that.
I'm also more towards 5 to 7. So to use them in collaboration with humans, to some extent, either as tools or as not yet another annotator.
Did you ever get to touch?
I think at Bing they are already doing that. Let's see let's see the
Will be ever a good idea to do that?
I don't think so, no, because we don't know the biases. It's a bit scary. It reminds me of the social media boom that we had and what the things happened with Cambridge Analytica. So we didn't look at the effects of social media on society and what can happen. And then at some point we realized it's being exploited. Also, if we do not really study the biases and what can happen if we do not regulate things, we cannot guess, we cannot predict where it can go. Thank you. See you at the coffee break.